The morning of July 8, 1944, broke grey and wet across the hedgerows of Normandy. Oberfeldwebel Klaus Baumer sat in the commander's cupola of his Panzer IV, watching the mist roll across the bocage like smoke from a dying fire. He had been awake for 36 hours. His crew had been in the same tank for 11 days. They had destroyed 4 American tanks in that time. They had also watched 19 of their own battalion's panzers burn. Baumer was not thinking about tactics or strategy that morning. He was thinking about a number. A number that had been whispered through the armored divisions since the landings began, 47. That was how many American tanks his battalion had counted rolling past their reconnaissance position in a single afternoon 3 days earlier. 47 tanks, moving in a column that took 20 minutes to pass. His entire battalion had started the invasion with 22 panzers. The Americans had just driven twice that number past a single crossroads, and they were doing it everywhere, simultaneously, across a front that stretched from Corentin to Cannes. What Klaus Baumer could not know, sitting in that wet Norman field with his fuel gauge reading 1/4 full and his ammunition racks holding 7 armor-piercing rounds, was that those 47 tanks represented less than 0.1% of the M4 Shermans that American factories would produce by the end of the war. He could not know that at that very moment, the Fisher body plant in Grand Blanc, Michigan was completing 1 Sherman every 43 minutes. He could not know that the Ford plant in Highland Park was running 3 shifts, 24 hours a day, and that the workers on the night shift had just beaten the day shift's production record. He could not know that there were more Sherman tanks being built in a single month in the United States than his entire nation would produce of all tank types in the entire year of 1944. What he did know was simpler and more terrible: they were never going to stop coming. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The mythology of German tank superiority has dominated popular imagination for 8 decades. The Tiger, the Panther, the technical sophistication of German engineering, these have become articles of faith in the narrative of World War II armored warfare. The M4 Sherman, by contrast, has been dismissed in countless books and documentaries as inferior, a tank that won through numbers alone, a mechanical mediocrity that succeeded only because America could afford to lose 4 Shermans for every German panzer destroyed. This narrative, repeated so often it has calcified into accepted truth, misses something fundamental about the nature of armored warfare, industrial production, and the psychological reality of men fighting in steel boxes. The Sherman did not win because it was the best tank. It won because it represented something the German military machine could not comprehend until it was too late: the transformation of war from a test of individual technical superiority to a contest of industrial systems. The Sherman was not a tank. It was a philosophy of warfare made manifest in steel, rubber, and explosive force. And for the men who faced it across the battlefields of Europe, it became something far more terrifying than a superior weapon. It became the physical embodiment of infinite American productive capacity, an enemy that could not be defeated because it could not be exhausted. This is the story of why German tank crews learned to fear not the individual Sherman, but what the Sherman represented. It is a story told through production figures, logistics reports, crew testimonies, and the cold mathematics of industrial warfare. It is a story that begins not on the battlefield, but in the factories, the training grounds, and the fundamental assumptions about how wars are fought and won. In the spring of 1940, when German panzers drove through France in what would become known as the Blitzkrieg, the armored doctrine that guided them was built on principles that had served Germany well in the First World War's final offensives and had been refined through 2 decades of clandestine development and Spanish Civil War experience. The Panzer Arm was conceived as a precision instrument, a concentrated force of technically superior vehicles manned by elite crews, smashing through weak points in enemy lines to create chaos in the rear areas. Quality over quantity. Individual superiority over mass production. The tank was a knightly weapon, operated by a warrior elite. This doctrine was not arbitrary. It emerged from Germany's specific industrial and resource constraints. Germany in 1940 lacked the raw materials for mass production of armored vehicles. It lacked the oil to fuel them in unlimited numbers. It lacked the industrial base to build simple, reliable vehicles by the tens of thousands. What it possessed was precision manufacturing capability, highly trained engineers, and a military culture that valued technical sophistication. The German answer to these constraints was to build the best tanks possible, not the most tanks possible. The Panzer III, Germany's primary medium tank in the early war years, embodied this philosophy perfectly. It was mechanically complex, carefully manufactured, and designed to be upgraded with better guns and armor as the war progressed. Its crews trained for months before seeing combat. Each tank was assigned a commander who had often spent years learning his trade. The maintenance requirements were substantial, but German doctrine assumed that proper rear area support and the rapid conclusion of campaigns would make this manageable. In Poland, in France, in the opening stages of the Soviet invasion, this approach worked brilliantly. German tanks punched through numerically superior but technically inferior and poorly coordinated opponents. But the doctrine contained a flaw that would not become apparent until the industrial base of the United States entered the war. The German approach to armored warfare assumed that the enemy's capacity to replace losses would be similar to Germany's own. It assumed that destroying 100 enemy tanks meant a significant delay before those 100 tanks could be replaced. It assumed that the enemy would run out of tanks before Germany did, that technical superiority would compound itself into strategic victory before the enemy could adapt. These assumptions were about to collide with an industrial reality that would invalidate them completely. Across the Atlantic, the United States Army was drawing very different lessons about armored warfare. In 1940, as France fell, the American armored force consisted of fewer than 400 obsolete tanks scattered across scattered infantry divisions. The U.S. had no armored doctrine, no mass-produced tank design, no industrial base configured for military production. What it did possess was something that would prove far more valuable: the largest automotive manufacturing complex in human history. The American automotive industry in 1940 was producing more than 4 million passenger vehicles a year. Ford's River Rouge plant in Dearborn, Michigan was the most integrated manufacturing facility on Earth, capable of taking in raw iron ore and coal at one end and driving finished automobiles out the other. General Motors operated dozens of facilities across the industrial Midwest, each one a cathedral of mass production. Chrysler, Studebaker, Fisher Body, Willis, the list of manufacturers went on, each one possessing expertise not in precision craftsmanship but in repetitive, standardized, high-volume production. When the U.S. Army Ordnance Department began designing what would become the M4 Sherman in early 1941, they were not trying to build the best tank in the world. They were trying to build a tank that American industry could produce in quantities that would overwhelm any opponent. The design specifications reflected this priority in every detail. The Sherman's engine was not cutting edge. Initially, it used the Wright R975 radial aircraft engine, a proven and reliable design that was already in mass production. When radial engines became unavailable because aircraft production took priority, designers simply fitted whatever was abundant: Chrysler multibank engines, twin General Motors diesel engines, Ford the 5/8. The Sherman was designed to accept multiple power plants without fundamental redesign. This was not a compromise. It was a feature. The Sherman's transmission was not the most sophisticated available. It was a straightforward mechanical design that a moderately skilled mechanic could repair with common tools. Its suspension was based on a modified vertical volute spring system that used ordinary steel springs rather than advanced torsion bars. The armor was homogeneous rolled steel, not the face-hardened plate that offered slightly better protection but required specialized manufacturing. Every component was chosen not for its individual superiority but for its manufacturability at scale. The Ordnance Department's specifications for the Sherman required that it be transportable by standard American railroads, fit on standard cargo ships, drive on standard pontoon bridges, and be maintainable with standard tools. It needed to be reliable enough that crews required only weeks of training rather than months. It needed to be reparable in field conditions by mechanics who were not specialists. And above all, it needed to be producible in numbers that would have seemed fantastical to any pre-war military planner. In February 1942, the first production M4 Shermans rolled out of the Lima Locomotive Works in Ohio. By the end of that year, 11 different factories across the United States were producing Shermans. The Fisher Tank Arsenal in Grand Blanc was building them in a facility that had been producing Buick components 2 years earlier. The Pressed Steel Car Company in Pennsylvania, which had made railroad cars, was building Sherman hulls. The Pacific Car and Foundry Company in Washington State, which had never built a military vehicle, was producing Sherman hulls and turrets. Ford's production facility in Highland Park was building complete tanks from scratch. Each factory was producing hundreds of tanks per month. The production rate accelerated through 1943 and into 1944. By the time of the Normandy invasion, American factories were completing more than 2,000 Shermans per month. That was 66 tanks per day. Nearly 3 tanks per hour. Every hour. 24 hours a day. 7 days a week. The German tank industry, by comparison, never produced more than 650 Panzers of all types in a single month, and that peak was achieved only once, in July 1944, when every available resource was desperately channeled into armored vehicle production. German factories were producing approximately 1/5 the number of tanks the Americans were building, and those German tanks were mechanically far more complex, requiring substantially more man-hours and increasingly scarce materials to manufacture. But the disparity in raw production numbers tells only part of the story. The deeper difference lay in the industrial philosophy behind production. American factories were not building individual tanks. They were building a production system designed to continue operating even under disruption. When a factory was damaged by fire or needed retooling, production shifted seamlessly to other facilities. When a component supplier failed to deliver, alternative sources were already identified. The Sherman was designed so that parts from one factory's production run were interchangeable with parts from any other factory's run. A transmission built in Detroit would fit perfectly in a hole built in Pennsylvania. German tank production lacked this systematic redundancy. The Tiger tank, introduced in 1942 as Germany's answer to Soviet heavy tanks, was manufactured primarily at the Henschel plant near Kassel. When Allied bombing damaged that facility, Tiger production effectively stopped. The Panther, Germany's most successful late-war design, was built at several factories, but each used slightly different tooling. Parts were not fully interchangeable. A track link from one production batch might not fit a tank from another batch. German maintenance crews became experts at field-expedient repairs because they could not rely on perfect parts compatibility. This might seem like a minor technical detail, but in the material reality of mechanized warfare, it was decisive. A Sherman disabled by a thrown track in Normandy could receive replacement tracks from any supply depot. Those tracks would fit. They would work. The tank would return to action within hours. A Panther with a thrown track faced a far more uncertain future. The crew might need to wait for a maintenance specialist to arrive with the specific track type. They might need to cannibalize parts from another disabled Panther. They might simply abandon the tank if the correct parts were not available within the operational time frame. The Sherman's reliability became legendary not because it never broke down, all mechanical systems break down, but because when it broke down, it could be fixed quickly and returned to action. American tank crews reported mechanical availability rates above 90% in many units. German tank crews, particularly late in the war, considered themselves fortunate if half their unit's Panzers were operational on any given day. But Klaus Baumer, sitting in his Panzer IV in a Norman field in July 1944, did not think primarily about availability rates or parts interchangeability. He thought about what he saw through his commander's optics. He thought about the growing realization that had settled over the armored divisions in the weeks since the invasion: the Americans were not running out of tanks. No matter how many Shermans German crews destroyed, more appeared. Always more. The tactical situation German tank crews faced in Normandy was unprecedented in their experience. In previous campaigns, destroying enemy armor created local superiority. Knock out a Soviet T-34 company, and you gain freedom of maneuver in that sector. Destroy a British tank battalion, and you bought time to reposition. But in Normandy, destroying American tanks seemed to accomplish nothing. The Americans would lose 4 tanks taking a position, and the next day they would have 8 tanks attacking the same position. German crews began to realize they were not fighting a conventional armored force. They were fighting an industrial system that treated tanks as expendable ammunition. The psychological impact of this realization cannot be overstated. German tank crews had been trained to believe in the superiority of their equipment and their training. They had been told that one German tank was worth 3 or 4 Allied tanks. And in terms of individual technical capability, this was often true. A Panther could destroy a Sherman at ranges where the Sherman's gun could not penetrate the Panther's frontal armor. A Tiger was virtually immune to frontal Sherman fire at combat distances. German crews had the advantage in armor, in gun performance, often in tactical positioning. But none of this mattered when the Americans could afford to lose tanks faster than Germany could destroy them. Bomber's Battalion had arrived in Normandy on June 12, 1944, with 22 Panzers and 4 command tanks. By June 30, they had 11 Panzers still operational. They had destroyed 37 Allied tanks according to their combat reports, 29 Shermans, 6 Cromwells, 2 Churchills. By any conventional military metric, they were winning. Their kill ratio was better than 3-1. Their crews were experienced. Their equipment, when operational, was superior. Yet they were losing ground every day. The Americans kept coming. They absorbed losses that would have crippled a German battalion and continued attacking. When Bomber's Battalion destroyed 4 Shermans attacking from the west, 6 more appeared from the south. When they ambushed an American column and knocked out 7 tanks, the Americans simply called for artillery and bypassed the position, leaving another battalion to reduce it the following day. The doctrine of quality over quantity, the fundamental assumption of German armored warfare, was collapsing under the weight of American production. The German crews were not being outfought tactically. They were being outproduced strategically. And there was no doctrinal answer to this problem, because the German military had never imagined fighting an opponent whose industrial base was so vastly superior that tactical victory became strategically meaningless. German intelligence had reported on American production capacity before the war, but the numbers had seemed too large to be credible. When reports reached the Oberkommando der Wehrmacht that American factories were planning to produce thousands of tanks per month, staff officers dismissed the figures as propaganda. No nation could build tanks at that rate. The supply chains required, the skilled labor force needed, the raw materials necessary, it was logistically impossible. But the reports were not propaganda. They were, if anything, conservative estimates. The Americans were not just building tanks faster than Germany. They were building tanks faster than Germany had imagined was physically possible. The Fisher tank arsenal in Grand Blanc, Michigan occupied more than 1.5 million square feet of manufacturing space. The facility employed more than 14,000 workers at peak production. In July 1943, the plant produced 375 complete Sherman tanks. That single factory's monthly output exceeded Germany's entire monthly production of medium tanks. And Fisher Tank Arsenal was just one of 11 major Sherman production facilities. The scale of American production extended far beyond the tanks themselves. For every Sherman rolling off the production line, American factories were producing spare parts sufficient to keep that tank operational for its expected service life. They were producing ammunition in quantities that allowed American tank crews to fire liberally in combat, knowing that resupply was certain. They were producing the trucks to transport those spare parts and that ammunition. They were producing the ships to carry everything across the Atlantic. They were producing the fuel to run the ships, the trucks, and the tanks. Germany was producing superior individual tanks while running out of everything else. By mid-1944, German tank crews were receiving strict ammunition rationing. Panthers and Tigers, with their powerful high-velocity guns, were issued limited numbers of the expensive armor-piercing rounds they needed to exploit their range advantage. Crews were ordered to hold fire until they were certain of a kill. Every shot needed to count because replacement ammunition was uncertain. American tank crews operated under no such constraints. Their ammunition supply was effectively unlimited by the standards of any previous war. A Sherman crew that expended its entire load of 71 main gun rounds in a single engagement would be fully restocked within hours, sometimes within minutes if supply vehicles were close. The Americans could afford to engage targets at long range, fire speculatively at suspected positions, use high-explosive rounds against infantry even when armor-piercing rounds would have been more militarily efficient. They could afford to be wasteful because waste, at American production levels, was not a strategic liability. The same disparity extended to every category of material. A disabled Sherman could be recovered and repaired if the damage was not catastrophic. American recovery vehicles were common, well-equipped, and supported by extensive repair facilities in the rear areas. A Sherman with a damaged transmission could be towed back, have the transmission replaced with a new one from depot stocks, and return to service within 48 hours. A disabled Panther presented a far more complicated picture. German recovery vehicles were scarce and often lacked the power to tow the heavy late-war tanks. Replacement parts for complex systems like the Panther's transmission were in chronic short supply. Field repairs might take days or weeks. Many disabled Panthers were simply stripped of usable components and abandoned because recovery was impossible and repair resources were needed elsewhere more urgently. The industrial differential extended even to crew survival and replacement. When a Sherman was destroyed in combat, crew survival rates were actually quite good by the standards of armored warfare. Approximately 80% of Sherman crews involved in tank losses survived, though many were wounded. This was partly due to the Sherman's design, which provided adequate escape hatches and relatively survivable internal layout, but primarily because of superior American medical infrastructure. Wounded crewmen received rapid medical attention, were evacuated to well-supplied field hospitals, and often returned to duty after recovery. German tank crews faced longer odds. The medical supply situation in German armies deteriorated steadily from 1943 onward. Wounded crewmen might wait hours for medical evacuation. Surgical facilities lacked supplies. Recovery rates declined. A wounded German tanker might be lost to service permanently even from injuries an American crewman would survive. More fundamentally, replacing trained crews became increasingly difficult for Germany as the war progressed. Each Sherman lost in combat represented a setback, but American training facilities were graduating thousands of replacement tank crewmen every month. Each Panther lost was harder to replace not just in terms of the vehicle but in terms of the trained crew to operate it. Germany's manpower reserves were exhausted. Training time was compressed as losses accelerated. By 1944, German tank crews were receiving a fraction of the training their predecessors had received in 1940 or 1941. The cumulative effect of these disparities created a battlefield dynamic that German armor doctrine had never anticipated and could not counter. Individual German tank crews might achieve local tactical victories, might maintain impressive kill ratios, might demonstrate superior marksmanship and tactical positioning. None of it mattered strategically because the Americans could afford to trade losses at a rate that would bankrupt any other military force. Klaus Baumer understood this in a visceral, experiential way that staff officers in Berlin could not grasp from casualty reports and production statistics. He understood it when his battalion requested replacement tanks and was told none were available. He understood it when his fuel tanks were refilled to only 3/4 capacity because fuel allocations had been reduced. He understood it when he watched American artillery pound a position for 3 hours straight, expending more ammunition than his entire division possessed, simply to soften resistance before an attack. Most of all, he understood it when he looked through his optics at the long columns of Shermans moving across the Norman countryside, dozens of them, their arrival as inevitable as weather, their numbers seeming to increase rather than decrease no matter how many his crew destroyed. The material reality of the Sherman was inseparable from the industrial system that produced it. The tank itself was not exceptional. Its armor was adequate but not outstanding, between 1.5 inches and 3 inches depending on location, sufficient to defeat most German tank and anti-tank guns at medium range but vulnerable to the high-velocity guns mounted on Panthers and Tigers. Its 75mm main gun was effective against early and mid-war German tanks but struggled against the thick frontal armor of late-war designs. The gun could penetrate the side armor of a Panther reliably, but frontal engagement was problematic unless the Sherman crew could maneuver for a flank shot. The Sherman's mobility was good, it was faster on roads than most German tanks and more reliable cross-country than Panthers, which suffered from problematic final drives. Its gasoline engine was a fire risk, particularly when penetrated by anti-tank rounds, but this reputation was often exaggerated. Post-war analysis showed Sherman internal fires were not significantly more common than in other tanks. The difference was that more Shermans were hit because there were more Shermans in combat. In pure technical terms, the Sherman was a competent but not dominant design. It succeeded not because it was individually superior but because American doctrine accepted that superiority was not the point. The Sherman's purpose was not to fight and win tank versus tank duels. Its purpose was to be present in overwhelming numbers, to support infantry advances, to maintain constant pressure, and to be so numerous that destroying them became a strategic impossibility for the enemy. This was a revolutionary approach to armored warfare, though one whose revolutionary nature was not immediately apparent to those experiencing it. Previous armor doctrine, whether German, Soviet, or British, treated tanks as capital assets that needed to be preserved and employed carefully. Losing a tank was a significant event that required investigation and analysis. The Americans approached tanks more like artillery shells, useful, expendable, and infinitely replaceable. This did not mean American commanders were cavalier with their crews' lives or indifferent to tank losses. But it did mean that American tactical doctrine accepted loss rates that would have been considered catastrophic by German standards. An American tank battalion might lose a third of its vehicles in a major engagement and be considered combat effective because replacement vehicles would arrive within days. A German Panzer battalion losing a third of its vehicles was effectively destroyed because replacements would take weeks or months to arrive, if they arrived at all. The psychological transformation this created in German tank crews was profound and well documented in post-war interviews and surviving wartime letters. In the early war years, German tankers rode home with confidence about their equipment and their prospects. Letters from 1940 and 1941 speak of superiority, of rapid victories, of the enemy's inability to match German tactical skill. By 1944, the tone had shifted dramatically. The letters that survived speak not of victory but of endurance, not of defeating the enemy but of surviving the enemy's inexhaustible resources. Underoffizier Werner Kastner, a Panther gunner with the 2nd Panzer Division, wrote to his brother in August 1944, "We destroyed 6 of their tanks yesterday. This morning 12 more arrived. We cannot win by killing their tanks. They have more tanks than we have shells." The letter was intercepted by Allied censors and preserved in intelligence files. It represents a sentiment that appears repeatedly in German correspondence from the Western Front in the summer and fall of 1944, the realization that tactical proficiency was irrelevant when fighting an opponent with unlimited material reserves. This realization did not lead to defeatism or collapse, which speaks to the quality of German military training and unit cohesion. German tank crews continued to fight effectively, to employ sophisticated tactics, to achieve impressive local results. But they fought with the knowledge that they were not winning, could not win, and that each day brought their inevitable defeat closer regardless of how well they performed individually. The specific tactics German crews developed to counter the Sherman numerical advantage reveal both their skill and their desperation. Unable to match American tank numbers, German armored units increasingly relied on defensive positioning, ambush tactics, and the exploitation of terrain advantages. They would position Panthers and Tigers in carefully selected firing positions that maximized their range advantage, allow Sherman columns to advance into kill zones, destroy as many vehicles as possible in the opening engagement, and then withdraw before American artillery could be brought to bear. These tactics worked, in the sense that they produced favorable loss ratios. But they were fundamentally defensive, reactive, and incapable of achieving strategic objectives. A Panther company might destroy a dozen Shermans in an ambush, but the Americans would still take the objective the following day with fresh tanks. The Germans were trading space for losses, and they were running out of space faster than the Americans were running out of losses. The battle for Ericourt in September 1944 provides a detailed case study of this dynamic. German intelligence had identified the 4th Armored Division's thrust toward the Moselle River as a significant threat. The 5th Panzer Army, one of Germany's most capable formations, was ordered to counterattack and destroy the American spearhead. The ensuing engagement pitted approximately 210 Panthers and Panzer IVs against roughly 280 Shermans and supporting armor. The German attack began on September 18, 1944, with multiple armored spearheads striking the American positions near Ericourt. In the opening engagements, German gunnery and tactical positioning proved superior. Panther crews destroyed American tanks at ranges exceeding 1,200 yards, well beyond the effective range of the Sherman's 75mm gun. The Americans took heavy losses, 14 Shermans destroyed in the first hours of combat. But the Americans did not withdraw. They repositioned, brought up additional tanks from reserve, called in air support, and concentrated overwhelming force against isolated German units. Over the following 5 days, the German offensive collapsed not because German crews fought poorly but because they could not sustain the losses they were inflicting and receiving simultaneously. The Americans lost approximately 30 Shermans destroyed beyond repair. The Germans lost more than 80 Panthers and Panzer IVs. The mathematics were stark. The Americans had lost roughly 11% of their engaged force. Within a week, replacement Shermans arrived from depot stocks. The 4th Armored Division returned to full strength and resumed offensive operations. The Germans had lost nearly 40% of their engaged force. No replacements arrived. The units were reconstituted with remnants of other depleted formations, but they never regained combat effectiveness. The 5th Panzer Army, as an offensive formation, had been destroyed by a battle it had won tactically according to traditional metrics. Post-war analysis of the Ericourt engagement reveals something that German commanders understood at the time but could not effectively counter: the Americans were learning. Early war Sherman tactics had been relatively unsophisticated, relying primarily on numerical advantage and aggressive forward movement. By mid-1944, American tank crews had developed tactics specifically designed to counter German technical advantages. When facing Panthers or Tigers, American Sherman platoons would coordinate to attack from multiple angles simultaneously. 1 or 2 tanks would advance aggressively, drawing fire and exposing the German tank's position. The remaining Shermans would maneuver for flank shots, where their guns could penetrate even heavy German armor. The tactic accepted that some Shermans would be lost in the approach, but if it resulted in destroying a Panther, the trade was strategically favorable. The Americans could replace 2 lost Shermans faster than the Germans could replace 1 lost Panther. American doctrine explicitly embraced this calculus. Training manuals from 1944 instructed Sherman crews on coordinated assault tactics that assumed losses during execution. The manuals did not pretend the Sherman could defeat a Panther in direct frontal engagement. They taught maneuver, coordination, and the aggressive exploitation of numerical advantage. They taught crews to think of themselves not as individual tanks but as elements of an overwhelming mechanical wave that would eventually swamp the enemy regardless of technical disparities. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. German commanders recognized what was happening but lacked the resources to counter it. Panzer Division's commander, General Lieutenant Fritz Bayerlein, wrote in his combat diary in July 1944, "The Americans have learned that they need not fight our tanks individually. They simply bring overwhelming numbers to each engagement. Our advantage in armor and firepower becomes meaningless when we face 4 or 5 of their tanks simultaneously. We destroy some, but the survivors destroy us. And tomorrow they have more tanks. We do not." The industrial disparity manifested in other ways that compounded the tactical problem. American tanks operated with an abundance of support vehicles that German units could barely imagine. Every Sherman company was supported by dedicated maintenance vehicles, ammunition carriers, fuel trucks, and recovery equipment. When a Sherman threw a track or suffered mechanical failure, recovery was often a matter of hours. The American maintenance echelon was itself mechanized and mobile, capable of keeping pace with advancing armored units. German tank units, by contrast, operated with increasingly threadbare logistics. Maintenance vehicles were scarce and often lacked proper equipment. Recovery of disabled tanks became problematic as fuel shortages worsened. Ammunition resupply was irregular and insufficient. By the fall of 1944, German tank crews could not assume that they would receive fuel, ammunition, or spare parts with any reliability. They fought knowing that mechanical failure might be as lethal as enemy fire, because a tank that could not move or fire was simply abandoned when the unit withdrew. The fuel situation became particularly acute. The Sherman's gasoline engine consumed approximately 1.5 gallons of fuel per mile under tactical conditions. This was not particularly efficient, but American logistics made it irrelevant. Sherman units received constant fuel resupply from tanker trucks that themselves seemed inexhaustible. American armored divisions could maintain offensive operations continuously because they never ran out of fuel. German tanks, whether running on gasoline or diesel, faced chronic fuel shortages from 1943 onward. The loss of Romanian oil fields, the Allied bombing campaign against synthetic fuel plants, and the impossibility of protecting fuel convoys from Allied air interdiction created a crisis that tactical skill could not overcome. Panthers and Tigers were sometimes immobilized not by battle damage but by empty fuel tanks. Crews would receive orders to attack positions they could not reach because they lacked the fuel to drive there. The tactical situation became absurd. Germany possessed some of the most capable tanks ever built, operated by well-trained crews, and they sat immobile for lack of fuel while American Shermans ranged freely across the battlefield. The Ardennes offensive in December 1944 brought this fuel crisis into sharp focus. Germany's last major offensive in the West was planned around the assumption that German armored units would capture American fuel depots in the opening days of the attack. The operation's success literally depended on stealing enemy fuel because Germany could not provide adequate fuel for its own offensive. When American resistance proved stronger than anticipated and German units failed to capture fuel stocks quickly, the offensive stalled not because German tanks were defeated in combat but because they ran out of fuel short of their objectives. The 6th Panzer Army, Germany's strongest formation in the Ardennes attack, included elite SS Panzer divisions equipped with King Tigers, Panthers, and Panzer IVs. In the opening days of the offensive, these units achieved significant penetrations and inflicted heavy losses on American forces. But by December 22, 1944, many German tanks were immobilized for lack of fuel. Kampfgruppe, one of the most powerful German armored formations, abandoned more than 30 tanks during its retreat not because they were destroyed but because they had no fuel to continue moving. Meanwhile, American armored units responding to the German offensive moved hundreds of miles in winter conditions, received continuous fuel resupply, and maintained offensive operations throughout the battle. The Third Army's relief of Bastogne involved moving an entire army group 90 degrees from its line of advance and covering more than 100 miles in winter weather. The logistics of this maneuver, the fuel required, the spare parts, the ammunition resupply, would have been impossible for German forces at that stage of the war. The material and psychological reality converged in moments of stark clarity for German tank crews. Oberfeldwebel Bomber experienced such a moment in late August 1944, after his battalion had been pushed back from the Falaise pocket. His Panzer IV had survived, though his crew was exhausted and their vehicle badly worn. They had been ordered to establish a defensive position along a road leading west from Argentan. The position was strong, good fields of fire, solid terrain, adequate concealment. They waited in position for 2 days. Bomber's crew had 9 armor-piercing rounds remaining. They had enough fuel to drive approximately 30 miles. Their radio was functional but they had received no communications from battalion headquarters in 18 hours. They did not know if the battalion still existed as a coherent unit. On the afternoon of August 20th, they watched an American armored column approach their position. Bomber counted the tanks through his optics. 37 Shermans in the main column, followed by at least 24 support vehicles. The American formation moved with casual confidence, not particularly worried about ambush. They were not moving like soldiers deep in enemy territory. They were moving like men who owned the battlefield and knew it. Bomber did not fire. His crew did not fire. Their 9 rounds would have destroyed perhaps 2 or 3 Shermans before return fire obliterated their position. The mathematics were simple and terrible. They let the column pass and withdrew under cover of darkness. The position they had been ordered to defend was abandoned without a shot fired because defending it was meaningless. The Americans were not pushing through resistance. They were rolling across a battlefield where resistance had become impossible. This was not an isolated incident. Similar scenes played out across France in the summer of 1944, across Germany in the winter and spring of 1945. German tank crews, often well-trained and equipped with technically superior vehicles, chose not to engage because engagement had become pointless. The loss ratio they might achieve, 2 American tanks destroyed for 1 German tank lost, 3-1, even 4-1, was strategically irrelevant when the Americans could sustain those losses indefinitely and German forces could not. The psychological weight of this reality broke men in ways that combat itself did not. German veterans of the Eastern Front, men who had survived Stalingrad or Kursk, found the Western Front more demoralizing despite lower casualty rates. Against the Soviets, German crews had fought an enemy who was also constrained by industrial and logistical limits. Soviet tank crews were brave and increasingly skilled, but Soviet logistics were strained and Soviet replacement rates, while high, were not infinite. A German tank crew could believe that destroying Soviet tanks mattered, that achieving a favorable exchange ratio contributed to eventual victory. Against the Americans, this belief was impossible to maintain. The Americans absorbed losses that would have crippled Soviet armies and continued operating without apparent strain. The material abundance of American forces became a psychological weapon more effective than any tank gun. German crews saw American soldiers eating chocolate and white bread in the field, saw them wearing new uniforms, saw them discard equipment that German soldiers would have considered valuable. The Americans operated with a material wealth that seemed almost contemptuous, as if the war were not a life-or-death struggle but an industrial exercise they were conducting with a fraction of their capacity. This was, in fact, accurate. The United States devoted approximately 40% of its GDP to war production at peak mobilization, a substantial commitment but one that left the American civilian economy functioning and productive. Americans at home experienced rationing and shortages, but they were not starving. They were not being bombed. Their factories were not being destroyed. The American war effort was enormous, but it was not existentially exhausting in the way Germany's total war economy was by 1944. The Sherman production program illustrated this differential clearly. The United States built 49,234 Sherman tanks during the war. Production peaked in 1943 and then deliberately declined in 1944 not because production capacity was exhausted but because military planners determined that existing production was more than sufficient for projected needs. Some Sherman production lines were shut down and converted to other military production because there were enough Shermans. Germany built approximately 6,000 tanks of all types in 1944, its peak production year. This included Panthers, Tigers, Panzer IVs, assault guns, and tank destroyers. Germany was producing at maximum capacity, straining every resource, and building 1/8 the number of tanks the Americans were building. And the American tanks were more reliable, easier to maintain, and supported by a logistics system that ensured they remained operational. The disparity extended to every category of military production. The United States produced approximately 300,000 aircraft during the war. Germany produced approximately 120,000. The United States built 2,700 Liberty ships and hundreds of purpose-built military cargo vessels. Germany built dozens of cargo ships and lost most of them to Allied action. The United States produced trucks, jeeps, and light vehicles by the millions. Germany relied increasingly on horse-drawn transport as truck production failed to meet needs. Every time a German tank crew encountered American forces, they encountered the physical manifestation of this industrial differential. The Shermans themselves were only the most visible element. Behind the Shermans came trucks carrying ammunition, fuel, spare parts, rations, medical supplies, and mail from home. American forward units operated with a level of logistical support that German units had not experienced since the early days of the war. American soldiers were well-fed, well-equipped, and could rely on rapid medical evacuation if wounded. Their equipment was maintained properly. Their tanks ran reliably because spare parts and qualified mechanics were abundant. German tank crews, by contrast, operated in an environment of increasing scarcity and deteriorating support. By late 1944, frontline German units sometimes went days without hot food. Medical supplies were critically short. Ammunition was rationed. Fuel was scarce. Spare parts for complex vehicles like Panthers were often unavailable, forcing mechanics to improvise repairs with inappropriate components or cannibalize disabled vehicles. The maintenance burden of Germany's technically sophisticated tanks became unsustainable when the logistics system could no longer provide proper support. The contrast created a psychological environment where German military professionalism existed in tension with the clear evidence of impending defeat. German tank crews knew they were skilled. They knew their vehicles were, in many respects, superior to what they faced. They could see, in individual engagements, that they were often tactically victorious. But they could also see, with absolute clarity, that tactical victory was meaningless when the enemy possessed unlimited reserves. This knowledge expressed itself in the behavior of German units in the war's final months. Some units continued fighting with remarkable effectiveness almost until the end, maintaining unit cohesion and tactical proficiency even in hopeless situations. Other units dissolved as soldiers concluded that further resistance was pointless. The difference was not cowardice or lack of skill. It was the variable human response to fighting when defeat is certain and the only question is how long to delay it. Klaus Baumer survived the war. His Panzer IV was destroyed by American aircraft in September 1944, but he and most of his crew escaped. They were assigned to another tank, a Panther this time, which they operated through the fall and into the winter. The Panther broke down repeatedly, suffering from the transmission problems that plagued the design. They spent more time repairing it than fighting in it. In December, during the Ardennes offensive, they ran out of fuel 15 kilometers short of their objective and abandoned the vehicle. Baumer spent the final months of the war as an infantry soldier, because there were no tanks to crew and no fuel to run them even if there had been. He was captured by American forces in April 1945. In the POW camp, he saw American supply depots that stretched to the horizon. He saw warehouses filled with equipment, stacks of fuel drums, rows of vehicles. The guards at the camp were well-fed, healthy, and casually confident. They treated their prisoners reasonably well, not out of particular mercy but because they could afford to. The Americans had so much material abundance that feeding thousands of prisoners was administratively trivial rather than logistically challenging. Baumer was interviewed by American intelligence officers interested in German perspectives on the Sherman tank. His responses, preserved in intelligence archives, are instructive. He acknowledged that the Sherman was inferior to the Panther or Tiger in armor, firepower, and crew protection. He stated that in equal numbers, German tanks were superior. Then he was asked if this made German tanks better weapons of war. His answer, no. Better weapons are the ones that exist in sufficient numbers to win. The Sherman was the better weapon because there were always more Shermans. We fought well. Our tanks were excellent. But you could afford to lose tanks faster than we could destroy them. That is the only statistic that matters in war. This was the fundamental lesson that German armored forces learned, too late to matter, that industrial capacity is itself a military capability, perhaps the decisive military capability in modern warfare. Germany had built the finest tanks in the world, operated by elite crews following sophisticated doctrine. But Germany had built 6,000 of them while facing an enemy that built 49,000 lesser but adequate tanks. Technical superiority could not overcome numerical disparity of that magnitude. The Sherman has been criticized, fairly, for design decisions that proved suboptimal. Its armor was too thin against late-war German guns. Its original 75mm gun was insufficiently powerful against heavy German armor. Its height made it an easier target than lower-profile designs. Its gasoline engine was a fire risk. American veterans who fought in Sherman often expressed frustration with these limitations. But these criticisms, while valid from the perspective of individual crew safety, missed the strategic purpose the Sherman fulfilled. The Sherman was not designed to protect every crew member in every engagement. It was designed to be producible in numbers that would overwhelm any enemy regardless of that enemy's tactical proficiency. It was designed to be present everywhere, continuously, in quantities that made defeat a matter of arithmetic rather than skill. The Sherman won because it represented the transformation of war from a contest of warriors to a contest of factories. German tank crews feared it not because it was superior but because it was infinite. They feared the knowledge that destroying Shermans accomplished nothing, that every destroyed Sherman was replaced before its wreckage cooled, that the supply of American tanks would outlast German ammunition, German fuel, German replacement crews, and ultimately German resistance. The material reality of the Sherman's dominance became even more apparent in the final offensives of the war. When American forces crossed the Rhine in March 1945, they did so with such overwhelming material superiority that German resistance, though occasionally fierce, was strategically irrelevant. American armored divisions drove deep into Germany not through superior tactics or better individual tanks but through the simple fact that they could maintain momentum indefinitely while German defenders could not. The logistics of the Rhine crossings illustrate the gulf in capability. The American Ninth Army's crossing at Wesel involved more than 2,000 artillery pieces firing a preparatory bombardment, followed by engineer units constructing pontoon bridges capable of supporting Sherman traffic within hours of the initial assault. Within 3 days, more than 1,000 tanks had crossed the Rhine and were advancing into the German interior. The Germans could destroy bridges, could fight delaying actions, could inflict local casualties, but they could not prevent the crossing because the Americans simply built new bridges faster than the Germans could destroy them. This pattern repeated across every major river obstacle in the final advance. The Americans would arrive at a river, bring up overwhelming engineering resources, construct multiple crossing points simultaneously, and pour armor across before German forces could concentrate enough strength to stop them. Each crossing involved more construction materials, more bridging equipment, and more logistical support than entire German divisions possessed for their entire operational area. German tank crews still fought in these final months, but they fought with the knowledge that they were delaying the inevitable rather than preventing it. The Panther and Tiger tanks that had seemed so formidable in 1943 were breaking down from mechanical wear, lack of proper maintenance, and operation by increasingly inexperienced crews. The training pipeline that had once produced elite tankers was producing teenagers with weeks of instruction rather than months. The fuel to train them properly did not exist. The ammunition to practice gunnery was unavailable. They climbed into their technically superior tanks and died because superior technology could not compensate for systemic collapse. American tank crews, meanwhile, were benefiting from accumulated experience and improved equipment. By 1945, many Sherman units were receiving the M4A3E8 variant, known as the EZ8, which featured improved suspension, a more powerful 76mm gun, and wet ammunition storage that reduced fire risk. The EZ8 was not superior to a Panther in frontal engagement, but it was good enough, and there were enough of them. More importantly, they were reliable, maintainable, and operated by crews who knew that if their tank was destroyed, they would probably survive and would definitely receive another tank within days. The psychological transformation that German tank crews experienced, from confidence in technical superiority to understanding that technical superiority was irrelevant, paralleled a broader transformation in military thought that would not be fully recognized until after the war. The Second World War marked the transition from warfare as a contest of military skill to warfare as a contest of industrial systems. This was not entirely new. The First World War had demonstrated the importance of industrial production. But the Second World War made it absolute. The Sherman was the clearest expression of this transformation. It was a mediocre tank that won through multiplication. It succeeded not by being the best but by being good enough and being everywhere. This was a fundamental challenge to military traditions that valued individual excellence, technical sophistication, and warrior elitism. Sherman suggested that in modern industrial war, these values were less important than production capacity, logistical efficiency, and systematic reliability. German military culture struggled to accept this reality even as evidence accumulated overwhelmingly. Post-war German military memoirs frequently emphasized the technical superiority of German equipment and the skill of German soldiers while attributing defeat to material disadvantages beyond military control. This narrative is not inaccurate. German equipment was often superior and German soldiers were generally well trained. But it misses the deeper lesson, that in industrial warfare, the side that can sustain production and logistics wins regardless of individual technical advantages. The American approach to the Sherman embodied a different military philosophy, one that German tradition found difficult to comprehend. American doctrine accepted that individual Shermans would be destroyed, that crews would be lost, that tactical engagements would sometimes be unfavorable. But American planning was not focused on individual engagements. It was focused on the cumulative effect of sustained operations supported by industrial production that the enemy could not match. This was not callousness toward American soldiers' lives, though German propaganda sometimes portrayed it as such. American casualty aversion was actually quite high compared to other combatant nations. The Americans invested heavily in medical support, in training, in equipment that would protect soldiers while still being producible at scale. The Sherman's design reflected this balance. It was not maximally protective of its crew, but it was protective enough while still being manufacturable in enormous quantities. The Americans were willing to accept that some Shermans would be destroyed and some crews would die, but they worked to minimize those losses while maintaining the production volume that strategy required. The German approach was reversed. German tanks like the Tiger and Panther offered better individual crew protection and battlefield performance, but at production costs that made them strategically counterproductive. A Tiger was a formidable weapon, but Germany built fewer than 2,000 of them during the entire war. The United States built more Shermans in a single month than Germany built Tigers in total. From a strategic perspective, the Tiger was a failure despite its tactical capabilities, because it diverted resources from producible weapons to showcase weapons that could not be built in decisive numbers. This was not obvious to German commanders at the time, and it remains a contentious point in military history. Individual Tiger crews who survived the war understandably valued the protection and firepower their vehicle provided. From their perspective, the Tiger was an excellent tank that gave them advantages in combat. But from a strategic perspective, every Tiger built represented resources that could have produced 3 or 4 Panzer IVs or assault guns, vehicles that, while individually less capable, would have provided more cumulative combat power simply through greater numbers. The Americans understood this calculation intuitively because it matched their industrial culture. American manufacturing had been built on principles of mass production, standardization, and cost efficiency. The automotive industry that became the arsenal of democracy in wartime was an industry that had learned to build millions of vehicles by making each individual vehicle simple, reliable, and inexpensive. The Sherman was an automobile industry tank, built with automobile industry methods, for an automobile industry war. Germany's industrial culture was different, rooted in craftsmanship traditions and precision manufacturing. German industry excelled at building complex, sophisticated products in moderate quantities. This approach worked brilliantly for peacetime manufacturing of luxury goods, precision instruments, and specialized equipment. It was catastrophically inappropriate for total war against an enemy with vastly superior productive capacity. The German military never fully adapted to this mismatch between their industrial culture and their strategic situation. Even late in the war, when the impossibility of victory was apparent to any rational observer, German industry continued developing ever more sophisticated tank designs. The King Tiger, introduced in 1944, was even more powerful than the Tiger, with thicker armor and a more powerful gun. It was also heavier, more mechanically complex, and more difficult to produce. Germany built fewer than 500 King Tigers. Each one was a masterpiece of armored vehicle design. Each one was also a strategic mistake, because the resources invested in building a King Tiger could have built multiple simpler vehicles that would have had greater cumulative impact. American tank development followed the opposite trajectory. The Sherman was continuously refined through the war with modest improvements, better suspension, more powerful guns, improved ammunition storage, but the basic design remained deliberately simple and producible. When American engineers proposed more radical designs that would have superior battlefield performance but lower production rates, the proposals were generally rejected. The military wanted more Shermans, not better tanks that would be available in fewer numbers. This difference in approach reflected different understandings of what modern war required. The Germans continued to believe, despite accumulating evidence to the contrary, that quality could overcome quantity if the quality differential was large enough. The Americans believed that quantity itself was a quality, that being able to replace losses faster than the enemy could inflict them was the most important military capability in industrial warfare. The Sherman's success validated the American approach conclusively. By the end of the war, American armored divisions had advanced from the beaches of Normandy to deep inside Germany, had liberated France and the Low Countries, had crossed the Rhine and seized German cities. They had done this while facing German armored forces that were, vehicle for vehicle, technically superior. They had won because vehicle-for-vehicle comparisons were strategically meaningless when one side had 8 times as many vehicles. Post-war analysis by both American and German military historians confirmed what German tank crews had learned experientially, that the Sherman won not despite its limitations but through deliberate design choices that prioritized producibility over individual capability. The American decision to build a good enough tank in overwhelming numbers was strategically superior to the German decision to build excellent tanks in limited numbers. This conclusion has been occasionally challenged by historians who focus on individual combat reports or tactical engagements, but the strategic outcome was unambiguous. Germany lost. The Sherman was a primary reason why. The human cost of this industrial approach was substantial for both sides. American Sherman crews suffered approximately 21,000 killed in action in the European theater. Each loss was a tragedy, each death a life that mattered to families and communities at home. The Americans did not win cheaply, and the Sherman was not a perfectly protective vehicle. But the Americans won, and Sherman crews knew throughout their service that they were part of a military machine that could sustain losses and continue fighting. German tank crew losses were proportionally far higher. Exact figures are difficult to establish because German record-keeping collapsed in the war's final months, but estimates suggest that more than 60% of German tank crewmen who saw combat in the war's final 2 years were killed or severely wounded. They fought bravely, often skillfully, in vehicles that gave them tactical advantages. But they fought knowing that advantages in individual engagements could not accumulate into strategic victory when the enemy possessed unlimited replacement capacity. The psychological burden of this knowledge was immense. Human beings can endure great hardship if they believe their sacrifice serves a meaningful purpose. German tank crews in the war's final year fought increasingly without that belief. They fought from discipline, from loyalty to comrades, from inability to conceive of acceptable alternatives. But many had ceased believing in victory and fought merely to delay defeat or to survive long enough to surrender to Western rather than Soviet forces. Klaus Baumer, in his post-war life, rarely spoke about his service as a tank commander. When he did, his focus was not on the technical details of armored combat or the tactical victories his crew had achieved. He spoke instead about the psychological experience of fighting an enemy whose resources seemed infinite, of the gradual realization that skill and courage could not overcome industrial capacity, of the strange mixture of pride in his crew's performance and awareness that their performance was strategically meaningless. He was asked once, decades after the war, whether he felt that German tank crews had been betrayed by leaders who sent them into combat with inadequate support. His answer was measured: "We were not betrayed. We were simply outproduced." Our leaders believed that German technical superiority and soldier quality would be sufficient. They were wrong. But it was not an unreasonable belief at the war's start. How could they have known that America could build 50,000 tanks while we built 6,000? How could anyone have predicted such a disparity? This question, how could German leadership have failed to understand American industrial capacity, has occupied historians for decades. The information was available. American industrial statistics were public knowledge. German intelligence reports contained accurate assessments of American production capacity. But the numbers seemed too large to be credible, and German leadership had no experiential framework for understanding what industrial warfare at American scale would mean in practice. Germany's own experience in the First World War had taught lessons about industrial production and logistics, but those lessons were about European-scale industry. The United States operated at a scale that had no precedent in military history. American factories produced more military equipment in 1943 alone than Germany produced during the entire war. This was not a marginal difference but a categorical one, and German military planning had no doctrine for confronting such disparity. The Sherman became the vehicle through which this disparity manifested most visibly. Other categories of American production, aircraft, ships, trucks, artillery, were equally overwhelming, but tanks were the most psychologically significant because tank combat was direct, immediate, and personal. A German tank crew faced Shermans directly, saw them destroyed, and saw more arrive. The experience was visceral in a way that abstract knowledge of American factory output could never be. The post-war period brought varied responses to Sherman's legacy. American veterans often criticized the tank, comparing it unfavorably to German armor and arguing that American soldiers had been sent into combat with inferior equipment. These criticisms were understandable from men who had experienced combat in Shermans and knew that German tanks could kill Shermans more easily than Shermans could kill German tanks. But the criticisms reflected a tactical rather than strategic perspective. German veterans, paradoxically, often defended the Sherman's design in post-war discussions. They understood, from the receiving end of American industrial might, that the Sherman's purpose was not to be the best tank but to be present in numbers that made German tactical superiority irrelevant. German tank crew memoirs frequently express a kind of reluctant admiration for American logistics and production capacity, even while maintaining that German tanks were technically superior. Modern military historians have largely concluded that the Sherman was an appropriate design for American strategic needs and that criticism of its limitations misses the fundamental point of its success. The Sherman won the tank war not by being better but by being numerous, reliable, and supportable at scale. This was the correct priority for industrial warfare, and the Americans understood this in 1941 when they designed the tank. The broader lesson the Sherman teaches, that industrial capacity is decisive in modern warfare, has remained relevant through subsequent conflicts. The principle that sustainable production of adequate weapons defeats limited production of superior weapons has been validated repeatedly. Nations that focus excessively on technical sophistication at the expense of producibility consistently underperform nations that balance capability with industrial scalability. This lesson was not universally learned. The Cold War saw both sides occasionally pursuing weapons systems so sophisticated and expensive that they could only be produced in limited numbers. The pattern repeated, showcases of technical excellence that looked impressive but provided less actual military capability than simpler systems built in larger quantities. Sherman's example, that good enough in overwhelming numbers defeats excellent in limited numbers, remains instructive for military planning. For the men who fought in and against Shermans, the technical debates were ultimately secondary to their lived experience. American crews remember the Sherman as the tank that brought them through the war, that was reliable when they needed it, that could be repaired when damaged, that was always available when needed. German crews remember it as the embodiment of American material superiority, the physical proof that they were fighting an industrial power they could not defeat. Both memories are accurate. The Sherman was both things, a mechanical system that worked reliably for its crews and a symbol of the industrial capacity that decided the war's outcome. It was never the best tank in any individual engagement, but it was the tank that won the war because there were always more of them, because they always worked, because they were always supported, because behind each one was an industrial system that could replace it overnight if necessary. Klaus Ballmer died in 1998 at the age of 76. He had lived a quiet post-war life, worked in manufacturing, and raised a family. He never owned a car, he walked or took public transport everywhere. When asked why, he would occasionally admit that he had spent enough time in motorized vehicles during the war and preferred his own feet. This was not quite true. The real reason, which he admitted to his son near the end of his life, was that every time he saw American cars on German streets, and Germany's post-war prosperity meant that American cars were common, he remembered long columns of Shermans rolling past his position in Normandy, remembered the knowledge that they would keep coming, remembered understanding that the war was lost because the enemy possessed resources that Germany could not match. He did not hate the Americans for this. He had come to understand, in the decades after the war, that American victory was inevitable once American industrial capacity entered the conflict. He had fought well, his crew had performed admirably, Germany had built excellent tanks. None of it mattered because the mathematics were insurmountable. The Americans could afford to lose tanks faster than Germany could destroy them, and that single fact had determined the war's outcome more than any other factor. The Sherman that sits today in the armor collection at Fort Moore, formerly Fort Benning, in Georgia is a standard M4A3 with a 75mm gun, built in March 1944 at the Grand Blanc Arsenal. It saw service with the 2nd Armored Division in northwestern Europe, was hit twice by German anti-tank fire, was repaired both times, and continued in service through the war's end. It was one of 49,234 Shermans built. It was not exceptional. That was the point. The Panther that sits in the Deutsches Panzermuseum in Munster, Germany, is a rarer artifact. Panthers were better tanks than Shermans by most technical measures, but Germany built fewer than 6,000 of them. For every Panther Germany produced, America built 8 Shermans. The Panther in the museum is beautifully restored, its systems maintained in working order, a testament to German engineering excellence. It represents a philosophy of armored warfare that lost to a philosophy that valued production over perfection. The two tanks, sitting in their respective museums thousands of miles apart, tell the story of industrial warfare more clearly than any tactical report or strategic analysis. The Sherman is common because it was meant to be common. The Panther is rare because rarity was built into its design philosophy. One approach won. One did not. The difference was not courage, not skill, not tactical doctrine. The difference was industrial capacity and the willingness to design weapons systems that matched that capacity's capabilities. German tank crews feared the Sherman not because it was fearsome in individual combat, but because it represented something far more terrifying than any individual weapon, the infinite productive capacity of an industrial power that had entered the war with resources Germany could not match, would not match, and could not defeat through tactical excellence or technical superiority. They feared it because destroying Shermans accomplished nothing when more appeared before the smoke cleared. They feared it because it demonstrated, with mechanical certainty, that the war was already lost. The Sherman won because it embodied a truth about modern warfare that Germany understood too late, that wars between industrial powers are won in factories as much as on battlefields, that the side that can produce adequate weapons in overwhelming numbers defeats the side that produces excellent weapons in limited quantities, and that technical superiority is strategically meaningless against an opponent with vastly superior productive capacity. These lessons, learned at terrible cost by men fighting in steel boxes across Europe, remain relevant for understanding how wars are fought and won in an industrial age. In the end, the Sherman was not remarkable because it was exceptional. It was remarkable because it was not exceptional, because it was good enough and there were always more of them, because it represented the transformation of war from a contest of warriors to a contest of factories. It won because America could build 49,234 of them while Germany built 6,000 tanks of all types. That disparity, more than any tactical consideration or technical specification, determined the outcome of armored warfare in the Second World War. The German tank crews who faced it understood this truth with terrible clarity. Their skill could not overcome that mathematical reality. Their courage could not defeat it. Their technically superior vehicles could not change it. They fought knowing they would lose, not because they were inferior soldiers or operated inferior equipment in any individual sense, but because they fought for a nation whose industrial capacity was 1/8 that of their enemy. In that context, every tactical victory was strategically meaningless, every destroyed Sherman was replaced overnight, and every battle won only delayed the inevitable conclusion. This was why they feared the Sherman. Not because it was the best tank, but because it was everywhere, always, in numbers that could not be defeated because they could not be exhausted. It was the mechanical embodiment of industrial warfare's most fundamental truth, that in a contest between quality and quantity produced at sufficient scale wins absolutely. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now and don't forget to subscribe.